Hello everyone. If you are looking for a highly scalable system design video, then this video is for you. In this video, I have taken the example of a system design of a URL shortener where in none of the layers there is a single point of failures. All the layers, including the database, is sharded and there are multiple machines in all the layers. So let's quickly get started. This is the overall requirement, that we have a very long URL and we want a very short URL in return. And the core requirement is that the backend should never go down. It does not matter how much load the system gets, it should never go down. This is the overall requirement. We have a requirement for a URL shortener. Around 1,000 million new URLs will be created per day, and around 100 times of that will be the read operations per day, which means around 1,000 new URL getting created per second and around 100k read per second. Now, why I'm saying these numbers is because on the left side, these 1,000 million and 100,000 million, these numbers seem very high. But when you divide by the number of seconds, then it comes to be something which you can feel that it is manageable. So 1,000 requests per second for the write operation and 100k read per second, that's the overall requirement. There's one important requirement that 50 GB of ever-growing database will be there. So on day 1, you need 50 GB of storage. On day 2, you need 100 GB. Day 3, you need 150 GB and so on. So that you don't buy everything on day 1 for next 10 years or so. You can buy for next 3 months or let's say an year, and you can keep on linearly scaling the database. This is the high level design of the system, that you would have two operations. One is create a unique ID and the other is get a URL by a unique ID. For example, if you want to create a URL shortener for google.com/a/b/c/d, something like that. So a request will come with the google.com/a/b/c/e and a unique ID will be generated. And in the database, we'll have a mapping of the unique ID to the long URL. So that's a create operation. The other will be the get operation, that now I'm giving the unique ID to the system and the system will respond me back with the long URL. So for example, a user who is using mobile or browser or anything, they will request that, hey, can you give me a long URL corresponding to this unique ID? Then it will respond with 302 result code, and you can design based on who is the client, etc. And it will give you the long URL. So that's the overall design. And we need to create two workflows. One is create a unique ID and the other is get URL by unique ID. There is some low level constraint as well, which we should understand. The first is that the unique ID should be created, of course. The second is the unique ID can have small a to small z, capital A to capital Z, 0 to 9, underscore and hyphen. So total 64 characters we can use. Some people or some websites would be talking about 62 characters. They don't include underscore and hyphen, and that is perfectly fine. Our maths will not change, just the number will change, and accordingly you can tweak everything. And yeah, the thing is that we do not want any conflict now. So I created one more video in which I talked about the conflicts as well, that at certain scale, conflicts are fine. You can just query the database and check that is the ID already generated or not. But if the scale grows so much that one single database is not enough or one single machine is not enough, in that case, you would not want to have a constraint on the database. So you want to guarantee that the ID generated by you is always unique, so that you don't have to rely on the database. And yes, there will be multiple shard and the multiple server systems in each of the layers. Now, if we talk about the unique ID generation problem, so there were two problems. One was around the unique ID generation and the other was around the reading the data from the database. So first we'll talk about the unique ID generation problem. I'll divide this problem into two parts. The first is, can I generate a unique number at a very fast rate? So for example, request number 1, return 0, request 2, return 1, 3, 4, 5, 6, 7, 8. The number of requests getting to you at such a high rate that you should be able to generate these numbers at the same rate. So are you able to do that? if you are able to generate the numbers at a very fast rate and those numbers are unique, and then you create a function of x where x belongs to all the natural numbers, let's say all the numbers starting from 0, then you will always have a unique ID. So if you create a unique function which always have one-to-one mapping from left to right, then you will be safe. So first we'll talk about the left part, that is how to generate the unique number at a very fast rate. And if we are able to do that, then we'll just pass that number into that function and we'll get a unique ID. So that's the overall idea which we'll do. Now let's talk about how to generate a unique number at a very fast rate. The naive approach would be that you have a server, a REST API, and you have a variable in memory. You don't even have a database. Whenever a request comes, you have a variable, you just update that variable. So for every new request, you keep on updating the variable. You take care of multi-threading stuff. So you can take a lock at that particular part where you update the variable, but still it will be very fast. So that's a naive approach. Now coming to even further, that you can have a database and you can call that database and have an auto increment counter. So whenever you make a call to the database, it will give you ID, which is incrementing 1, 2, 3, 4. For each new request, it will keep on giving you unique ID. Now the problem is that the database or one single server will have a problem because that server could go down, and beyond a certain limit, that server cannot scale. So if at all you have such a high load on the database or on your server, then you have to distribute. So what we do is that the moment you launch a server, on server startup, it will make an API call to a range assigner service. So I will create one service which will just return me the range 0 to 1 million, 1 million 1 to 2 million, 2 million 1 to 3 million. So this range will be given by this service. So whenever a server is launched, the range will be assigned with this service, and this service can be very lightweight because how many servers will have? 50, 100, 1000, but still it is not much of a load. So the number of requests coming to this server will be very less. And I'll maintain a database which will just have a range, so that whenever a new request comes, this server will check what is the range which is free and it will give you the number. And this number is indefinitely increasing. So in this way, even after, let's say 5 trillion, 6 trillion, you don't even care because you will always have a bigger number more than the previous number. So you have a very lightweight range assigner service. Whenever a service is launched, it will call this server to get the unique range. The logic can be anything, whatever you want to. For example, you can have a unique counter in the database, and with the help of that, you multiply by 1 million and give a range, or whatever logic you want to, because it will be a very lightweight server, and this will be called only on the launch of these services, only on the launch or when the range is finished. For example, if this server has reached the range of 1 million, then it will call again and ask, can you give me more? So in this way, the segregation will be done. The server 1 will have this range, the server 2 will have this range, server 3 will have this range. So in this way, all of them will have unique numbers, and whenever a request comes to the server, it will have in-memory variable which will be incremental automatically. So that's how you can generate the numbers at a very fast rate. Now let's talk about function to generate unique ID from numbers. Now you have been able to generate the numbers and they are very much unique. But can you have a URL something like this, short.co 1 2 3 4 5 6 7 8 9? The problem with this approach is it will grow very long. So imagine you telling somebody a URL like a phone number, and not even phone number, even bigger than phone number, because these numbers will grow at a certain pace. For 100 3 digit, you will very quickly reach 4 digit, you will very quickly reach 5 digit. So how do you make them smaller? So if you see, this is a base 10, which means that each of the index can be filled with 10 options, 0 to 9, 0 to 9, etc. So if you, instead of having base 10, now since you have for each of the index, you have 64 options, 0 to 9, A to Z, and these are the 64 options. So why not use 64 base 64 of a particular number and then store that? So the number of characters is inversely proportional to the base. So if you have base 64, then you have a smaller number of characters compared to the lower base. Imagine you have base 2, then how long this particular number could be, 0, 1, 1, 0, 0. It will be very long to convey the same data. But if it is base 10, you are able to convey the same data in 9 characters. But if it is base 64, you are even able to make it smaller. So now since you have 64 options, we'll convert it into the base 64. And let's see how. So what I'll do is that I'll have an array of 64 length. So index 0, 1, 2, 3, 4 up to index 63. And what I'll do is I'll assign these values to that array. 0 to 9, then A to Z, capital A to Z, hyphen and underscore. Now what I'll do is, this is the pure computer science fundamentals we learned long back, that how do you convert decimal to a particular base. So this is a decimal. You write 64 here because we want to convert it to a base 64. You can divide this one. So this is the quotient and this is the remainder. 14 is the remainder and this is the quotient. Then you divide again, you put the remainder here. You divide again, put the remainder here. And likewise, you can keep on getting the remainder. So 64 divided by this number 1, 2, 3, 4, 5, 6, 7, 8, 9 will give the quotient as 1929012 and the remainder at 14. Again, if you divide this number by 64, you will get 3014 as quotient and 5 as remainder. Again, you will get 47 as quotient, 6 as remainder, and eventually you will get 0 as quotient and 47 as a remainder. So this is how you can get that done, and you can write a plain Java or any code you want to. So now what we'll do is we get the numbers 14, 5, 6, 47, and then we'll search for the index. 14 is E, 5 is 5, 6 is 6, and L, capital L is 47. So in this way, we reach base 64. Clearly, you can see the 9 characters get converted to the 4th character and you create a short URL. Now, since we have already checked how to create the short URL, now let's talk about how to get the long URL from the short URL. You will share that short URL to someone and they will request to your server. The requirement is that you should not be taking any lock to your system, and it's an ever-growing DB. So the great solution to this is Cassandra. You can have your own shard logic where you can create the databases, but all these things are already given by default in Cassandra. So it's a ever-growing database, linearly growing database. So today you need 2 server, you launch 2 server. Tomorrow you need 3rd server, you put 3rd server in the same Cassandra cluster, and Cassandra cluster will scale. So whenever you have ever-growing database, you can use Cassandra. Here you can use any other database as well, because this particular problem is solved by other database as well. You might have more maintenance, but it is completely your choice. The thing is that there will be certain databases where you need to maintain the shards on your own, whereas some will manage the shard themselves. So that's the only difference. But yeah, you need to use a NoSQL databases because strictly no lock needed anywhere. Now, if I bring everything together, this is the overall system design of the URL shortener, of a highly scalable URL shortener. You will have a range assignment DB. This will be a very short database because the number of requests coming to this will be very low. Maybe in an hour, you would get requests in orders of hundreds, not even hundreds. So whenever a server is launched, they will make a request to the assigner service where you can have whatever logic you want to and give the range from 0 to 1 million, 1 million, 1 to 2 million, etc. Whichever range is free in the database, you give them that. And once you have that range, you can have an in-memory variable. Whenever a request comes to your server, then you increment the variable, you convert the variable to a base 64 as the method we discussed earlier. Then we know that that value will be unique because the number is unique, and we'll store that value in the Cassandra database. Now, why that number will be unique? Because it's just a conversion of decimal to the base 64. So these mappings of the number system are always 1-to-1 so that you can convert base 10 to base 64 or base 64 to base 10. It will never happen that you will have 2 outputs of base 10 to base 64 or vice versa. So this conversion is always unique. And now since you have guaranteed that number to be unique, it will be unique. Now this Cassandra database is a scalable database. It has multiple nodes or multiple servers in itself. So initially you need 50 GB of storage per day. You can keep on adding machines. And whenever you get a lesser load or people delete their data, then you can even remove the nodes if you want to. So that's it. That's the overall design of a URL shortening service. Let me know how you like this video. And if you really want it, I will create a video on the coding part as well. And I'll code this particular design end to end. It's not much. If you see the design, the range assigner service, or that this database, this can be any database you want to, even the most lowest database will do the job for you. This Cassandra is also very easy to set up. And these are the services. You can keep on launching those services and access the database. So if needed, I'll definitely love to create a video on the designing and coding of this whole system. But I hope this video was very helpful to you. Till the next time, bye.